Good morning, everybody, and welcome to our pre-calculus class today. Um, so we are still working on our trigonometry on chapter number 6. We started the lesson 3 last week, and we mainly focused on introducing the radian measure. So we've changed or converted from degree to radian and then radian to degree. And then, and then last week we also talked about coterminal using the radian measure. So today what we're going to do is we're going to keep working on that particular lesson. We're going to go from page 18 onwards. So let's go right ahead in this one here. This is the page that we're going to be working on right now. And I think there's so much stuff in here that I'm going to be using a separate sheet of paper to write all of my notes so that I can show all of the steps. Okay, so let's go right in here. I'm just going to write down page 18, and this is on trig. So let's take a look at example number 2. Let's read it first. It says here, in example number 2, for each trig ratio given, determine the exact values of the 5 other trigonometric ratios for theta given the domain. And that's the first part. And then the second part is to the nearest tenth of a radian, determine the possible values of theta in the domain between negative 2 pi to positive 2 pi. So we are basically from negative 2 pi to positive 2 pi radians. Let's take a look. So example 2. So let's do a sine theta is equals to 2 over 9. Now this one here, we're just looking for between 0 to 2 pi. And these are in radians. So we don't put the degree there, okay, because these are radians. So sine is equal to 2 over 9. So when we look at this part in here, sine is 2 over 9. We can look at it in two different ways. We can say this is going to be opposite, and then this is the hypotenuse. So if we could visualize that way. So if we can say sine theta is equals to 2 over 9. So this one here is wherever the angle is, this is the opposite side, and then this is the hypotenuse. We can look at it that way. So I like to draw it out so we can see what's going on in here. Okay. Because sine is positive, we got to ask ourselves where or which quadrant where is sine positive. Okay, well, sine is positive, so if we use a CAST method or CAST acronym in here, sine is positive in quadrant 1 and quadrant 2. So in quadrants 1 and quadrant 2. So this is important because we need to find all possible solutions. So where is sine? Right here. And it could be right here. Okay. So if we draw our triangle in here, so I'm going to drop a perpendicular line there. So this is my theta in standard position. Opposite is 2. Hypotenuse is 9. So 2 over 9. But this could also be true in this side. So if I go to this angle right here, so starting from our initial arm being on the positive x-axis turning this way. So this is our theta in standard position. So we can use our theta r, and the opposite is 2, and adjacent, no, we don't know what the adjacent is, and hypotenuse is 9. So 2 over 9. Okay, so we got two possible answers, one in quadrant 1 and then one in quadrant 2. How do we figure out the other trig ratios? So to figure out the other trig ratios, we need to figure out the x, the adjacent for this triangle, and then the adjacent for this triangle. So how do we do that? Let's just focus on this one first because it's going to be very, very similar for quadrant number 2. How do we do this one here? We could go like this. X squared plus y squared is equals to r squared. So x, we don't know. X squared plus y squared is going to be 2 squared is equals to 9 squared. So that's going to give us x squared is equals to 9 squared minus 2 squared. 81 minus 4 is equals to 77. Now, when we take the square root of each side, this is where we're actually going to see that we can have a positive plus and minus root of 77. So that means the x is on quadrant 1, this is going to be plus or positive root 77, but on quadrant number 2, this is the one that's going to be negative root of 77. Now that we have all of the parts complete, okay, so we can just say, we can do the other trigonometric ratio. So we already have the sine. Sine is opposite over hypotenuse, which is 2/9. Cosine of theta is equals to adjacent over hypotenuse. So it's going to be positive 77 over 9. So that's that one. But it could also be this part in here. It's going to be negative 77, root of 77 over 9. So this is going to be plus or minus root of 77 over 9. Tangent. Tangent is adjacent, opposite over adjacent. So opposite is going to be 2 over root of 77. But remember, we're going to remember here. We're going to remember here that one is positive and one is negative. So tan could be plus and minus as well, right? Because we have opposite over adjacent, but in this particular case is opposite over adjacent as well. So it's plus and minus. Tan of theta is equals to plus or minus 2 over root of 77. So we got the three primary trigonometric ratio. Now what we're going to do is the other three, which are reciprocal. So if the cosine is plus or minus root of 77 over 9, then that means secant, we can go secant theta is equals to the reciprocal of that. So it's still plus or minus 9 over root of 77. And then cotangent theta is equals to the reciprocal of tan theta. So if we just take the reciprocal of this, we're going to get plus or also plus or minus 2 over root of 77. And then the last thing that we got to do is, because we have a sine theta, I'll just write it down over here. We already know that this is the given. sine is positive 2 over 9, then that means the cosecant theta is the reciprocal of sine, which is 9 over 2. Okay, so as you can see, I had mentioned earlier that I need to use a separate sheet of paper to do this because it's quite a bit of stuff to do. Okay, it's not just one step, but it's multiple steps in this particular case. Okay, so that's that part. So that's a part 1. We've determined the 5 trigonometric ratio. Now, the other thing that we got to do is to find the angle, but the angle in radian measurement. What is the angle of that measurement? Now, to do that, we have to go to our calculator, and we had to make sure that our calculator is in radian mode, okay, because we're talking about radian measurement. We have to change that. Mine says degree in here. So each of our calculators are different, so we just have to change it in radian mode. Okay. If you need help in figuring that out, just let me know, and then by email, and then maybe I'll walk you through that. But it has to be radian. So what can we do? Find the theta. This is 1. I'm going to do part 2. So far we did sine theta is equals to 2 over 9. So we're going to calculate theta. How do we calculate theta? So we go take the sine inverse of 2 over 9. Okay. I am sure that you are capable of doing this. This is a grade 10 grade calculus. So take the sine inverse of that. So sine inverse of, I have to put the brackets, 2 divided by 9. And I'm going to get a 0.22 radians. So the angle here is 0.22 radians. Now the 0.22 radians is actually the reference angle in quadrant 1. So they're telling us that this one here in quadrant 1 is 0.22 radians, which is also, we can say that's also the reference angle of 0.22 radians. So if the reference angle is 0.22, then there's a reference angle over here also at 0.22. Okay, so what are the two angles that we have to two solutions? So the two solutions are okay, so we have to state the one in quadrant 1. So in quadrant 1, in quadrant 1, theta is equals to 0.22 radian. And then in quadrant 2, theta is going to be, so in quadrant 2, it's going to be from here to here. It's from here to here is going to be pi radians, pi minus 0.22 radians. So it's going to be pi minus 0.22 is going to give us 2.92 radians. Okay, so that those are the angles in quadrant 1 and in quadrant 2. Now, the other thing that they had they had asked is determine the nearest tenth of a radian. Oh, nearest tenth, that should be just one decimal places. Possible theta for the domain negative 2 pi to 2 pi. So these angles are only from 0 to 2 pi. So what we need to do is we need to figure out the other coterminals. So other coterminals for these ones are, so this is going to be the coterminal for that part there. That's the first one. And then the other way, if we go to a negative 2 pi, what would be the coterminal if we turn around the other way? So coterminal would be 0.22 minus 2 pi times negative 1 plus 2 pi times negative 1. Okay, so this is the lesson that we talked about last week on Friday, finding the coterminal. So 0.22 plus 2 pi times negative 1. So it's going to give us a negative 6.06 radian. Okay, so in this particular case, this in quadrant 1, we can read the angle going this way in a positive direction, but we could also read the angle this way in a negative direction, clockwise, and we're stopping at this angle right there. That's our terminal arm. The other coterminal for this one, now we're going to talk about this angle right here. We can, 2.92 is this angle from positive initial arm here on the positive x-axis going this way, but we could also turn clockwise, which is a negative angle. Coterminal for that. Okay, so this is our angle, so 2.92. And if we're going to turn the other way around this way, it's going to be negative, no, so plus 2 pi. And then we're going to turn around negative direction, so times negative 1. (2.92) plus 2 pi times negative 1. We're going to get a negative 3.36 radians. Okay, so in terms of our theta, so there, the solutions are okay, so we have a 0.22 radians, negative 6.06 radian, 2.92 radian, and negative 3.36 radian. We have four solution in that particular case. Okay, so that's that part. Well, yeah, it's a long one. It's not a short. There's so many things to unpack here. So let's take a look at question B. What does question B look like? Pretty much the same thing. Example 2. And we're going to do B. In this particular case, the given information is the tangent of theta is equal to negative 12 over 7. I'm just going to put the negative in the numerator and then 7 in the 7 is a positive. Okay, so what does that mean? What do we know about tangent? So tangent is opposite over adjacent. We know that's opposite over adjacent. And then let's see if we can figure this out. The question is, where is tan negative. Where is tangent negative? So if we do the cast, C-A-S-T, okay, so that means A in quadrant 1, all trig ratios are positive. Sine is positive here. Tan is positive in quadrant 3. And then only cosine is positive in quadrant 4. Where's tan negative? So tan is positive here in quadrant 1 and 3. So tan is negative in quadrants 2 and 4. In quadrants 2 and 4. Okay, so what does that mean? Let's draw it out. Okay, so tan is negative there and there. We're going to have to use our reference angle. In this case, a reference angle, okay, to create a right triangle here. So it's going to be opposite over adjacent. So the opposite is 12, okay? Opposite is a positive 12. And then the adjacent in this particular case is the negative 7, okay? Because the opposite is the y, it's a positive, and then the adjacent would be the negative 7. Now over here, the opposite, the y is negative, so it's going to be negative 12 here, and then the adjacent is positive. Okay. Got two possible solutions that way. Okay, so what can we do? Well, we're missing the radius here. Okay, if we have a circle around here, we're looking for the r. So how do we figure out the r? So r is equals to x squared plus y squared. Okay, so r is equals to 7 squared plus negative 12 squared. Okay. That's r squared. So that's going to give us 49 plus 144. 49 plus 144 is 193. And then we want just r. R is equal to the square root of 193. And that's to be exact. We're not going to round this off. We're going to just keep it as a square root of 193. So we're going to write down the trigonometric ratio. So trigonometric ratios are, okay, so cosine theta is adjacent over hypotenuse. So adjacent is 7 over hypotenuse of 1 root of 193. But we have adjacent over hypotenuse here. Oh, that's 193. But this one here, if we're looking at this angle over here, adjacent is a negative, hypotenuse is a positive. So in terms of cosine, we're going to have plus or minus 7 over root of 193. Okay, so this is going to be 7 adjacent over hypotenuse. That's 7 over the root of 193. Or you can look at this triangle over here. This is adjacent over hypotenuse, so negative 7 over root of 193. That's why we had to do plus or minus for the value of cosine. Now what about sine? So sine theta is adjacent, opposite over hypotenuse, sorry. Opposite over hypotenuse. So if this is my angle, opposite is negative 12 over hypotenuse of 193. Now, if you take a look at this angle over here in quadrant 2, opposite is positive, hypotenuse is root of 193. So this one is also a plus and minus, plus minus. So we got two possible solutions for this case. So it's either a plus 12 over 190, root of 193 or negative 12 over 193. And then finally the tan of theta is equals to negative 12 over 7. So we have all the three primary trigonometric ratio. What we're going to do is we're going to do the reciprocal ratios, trig ratios. Secant theta is the reciprocal of cosine, so it's going to be still plus or minus root of 193 over 7. And then cosecant theta is the reciprocal of sine, so it's going to be plus or minus root of 193 over 7. And then tangent, the reciprocal of tangent would be the cotangent of theta, which is the reciprocal of that. It's negative 7 over 12. Okay, so these are all of our trigonometric ratios. That's just for part 1. Now for part 2, we're going to look for the angles. Okay, so what are the angles in this particular case? What we need to do is we need to tangent theta is equals to negative 12 over 7. So to figure out theta, we're going to take the tan inverse of each side of the equation. Okay, so tan inverse of negative 12 over 7. Let's figure that out on our calculator. Okay, so I got a negative 1.04. Negative 1.04 radians. So actually this particular radian, this particular angle that they gave us is the angle, the negative angle, which is in quadrant 4 because it's a negative. So that means, okay, so that means I'm going to redraw it out again so that we have this in front of us. So our calculator is telling us, hey, this is going to be a negative 1.04. That's our angle. If this is negative 1.04, then that also tells us that because we're turning this way, our reference angle will be 1.04 as well up here. Okay. Now, our calculator, because they gave us a negative, it can only detect or calculate one solution. We have to really seek out the other possible solution, which is in quadrant number 2. So our reference angle here is positive 1.04. So what we're going to do is we're going to look for all of the angles. So solution in quadrant 2. In quadrant 2, it's going to be from here to here is pi minus 1.04. And that will give us this angle this way. It's going to be 2.10 radian. And then the other one is negative this way. So what we need to do is we need to find all coterminals. Coterminals. Hmm. In quadrant 4, it's going to be negative 1.4 this way. To go from positive angle would be go that way. Okay, so we could find the positive coterminal of this one. We know it's going to be negative 1.04 plus 2 pi. And if we multiply it by 1, that means one rotation positively, we're going to get the positive coterminal. So negative 1.04 plus 2 pi times 1. It's going to give us the 5.24 radians. Okay, so we have radians going this way. We have that one. Right, from here to here, that's a positive 2.10. Now to go from here to here is negative 1.04 plus 2 pi is 5.24. Finding the coterminal there. Now the coterminal to go the other way around in a negative direction, that would be we can say that it's going to be 2 pi coterminal. Okay, 2.1 plus 2 pi times negative 1. Negative 1 means going around to the negative direction. Negative 4.18 radians. And then if we just go this way, we have our, so we have this angle, a positive angle, which is 5.24, and then we have a negative angle of negative 1.04 there. So the solutions for theta are 2.10 radian, negative 4.18 radians, negative 1.04 radians, and then finally 5.24 radians. So we have 4 solutions in that case. Okay, so that's example 2, part B. I'm going to post this on the blog as soon as we are completely finished here with our live streaming. Just if you didn't catch all of that, just don't worry, we'll get there. So now what we're going to do is on page 19. In this particular case, we are not given the trig ratio. We are given the point on the graph. So point on the graph. So where is that going to be? Again, it says here, determine the exact values of this time 6 trigonometric ratios. And we're also going to look at the possible theta, possible angle within this frame here. Okay, so let's see here. This is page 19, example 3. Letter A. The given the point of negative 5, 2. Well, let's visualize where negative 5, 2 is. So negative 5, 1, 2, 3, 4, 5, negative 5, positive 2, and right there. So that means our terminal arm goes through the point negative 5, 2. Negative 5, 2. So this is our x, negative 5, 2. So x comma y. So negative 5, positive 2. We need to figure out the r, the radius, to go around in a circle. So find the radius first. Okay, we've seen this one before in lesson 1. So x squared plus y squared is equals to r squared. Negative 5 squared plus 2 squared is equals to r squared. 25 plus 4. So that's going to be r squared is equals to 29. So that means the radius is the square root of 29. And radius is going to be always positive. So what are the three trigonometric, no, 6 trig ratios in this case? So this is, I'm going to write down root of 29 in here. And this is our theta r. And from here to here is our theta. Okay. So our theta is from here, standard position, that way. And then our theta r is in the inside of the triangle. So cosine of theta would be adjacent over hypotenuse. That's going to be negative 5 over root of 29. Sine theta is opposite over hypotenuse. So it's going to be 2 over root of 29. And then tangent of theta is opposite over adjacent. So it's going to be 2 over negative 5. Now that we have the primary trigonometric ratio, we're going to do the reciprocal trig ratio. So if cosine of theta is negative 5 over root of 29, then that means secant theta is the reciprocal of cosine. So it's going to be root of 29 over 5, and it's going to be a negative. So negative. You can put the negative at the front, or you can put in the denominator. It doesn't really matter. Cosecant theta is the reciprocal of sine, so it's going to be positive root of 29 over 2. And then finally, cotangent theta is equal to the negative 5 over positive 2. Okay, so this one is a lot shorter than the other one. Now let's see. This is the part 1. Part 1. The part 2 is figuring out the possible values of theta. Now between 0 to 2 pi. Because we're only interested in from 0 to 2 pi right there, there's actually only one possible solution. One solution here. So we go, which one can we choose in this particular case? We can choose either the sine, we can use the cosine, we can choose anything. So we can just figure out we can use sine, cosine, or tangent. Doesn't really matter. But in this particular case, what we need to figure out first is the reference angle. So if we use cosine theta is equals to negative 5 over root of 29, we're just going to see that for a second. Negative 5 over root of 29. We're going to end up with an angle. Oh, actually, we might get the actual angle. So cos inverse of negative 5 divided by the square root of 29. It's going to be 2.76 radians. So from here to here, we're going to get the 2.76 radian. What happens if we use sine 2 over root of 29? Okay, what if we use 2 over the root of 29? So I'm just gonna take a look, take the time to do that one. What if we use sine theta equals to 2 over root of 29? What would happen? Let's see here. Sine theta is equals to 2 over root of 29. So theta is equals to sine inverse of 2 over root of 29. And you'll find that we're going to get a different answer. So 0.38. And we're probably thinking, well, why are we getting two different answers, right? So in this particular case, our calculator doesn't know which quadrant we're operating in. Okay, so our calculator, although it can calculate some stuff, it does not understand that theta is in quadrant 2. So if you use the sine theta ratio, we're going to end up with this particular case, which is 0.38, but that's a 0.38 reference angle. This is the reference angle. Okay, so that's actually not the theta, it's a reference angle. So if we wanted to find theta, okay, so what they actually did is the calculator thought that we are in quadrant 1, and this is our reference angle that got calculated, 0.38. Okay, so your calculator is smart, but not as smart as you are. So we have to look at, hey, if that's a reference angle of 0.38, then this is also 0.38. Okay, so we don't want the reference angle, we want the angle itself. So we're going to go from here to there. So therefore, theta is equal to pi, okay, because from here to here is pi radians. And then we're going to go back, so minus 0.38 radians. And if we do that, so pi minus 0.38, we're going to get the 2.76 radians as well. Okay, so I thought I'd discuss that because if we use the sine ratio, we're going to end up with a different answer. Okay, but if we use the sine ratio, we have to keep going to figure out the actual theta. So that's the only thing that's for that one. Okay. Now let's see this letter B. The point example 3, the point 3, -7. Oh, we have here, in this particular case, our domain is from -4 pi to 4 pi. Okay, so we need to go as to the -4 pi to positive 4 pi. So -4 pi is approximately -12.57, and then positive 4 pi would be positive 12.57 radians. Okay, so this is, I'm just figuring out the decimal, so I know we're going to end up with the coterminals here or find the coterminal. So let's visualize what this looks like. Okay, we need to visualize it because if we can't see it, we can't solve it. If we can't see it, we can't understand it. Where is 3, negative 7? So positive 3, 1, 2, 3 on the x, and negative 7 for y. 1, 2, 3, 7. Okay, so that point is in quadrant number 4. So x is 3, negative 7. So that means this is 3, negative 7 for y. So what's our angle? What's our theta? So we could go from here all the way down there, right? But before we get to that one, what we need to do is we need to figure out the 6 trigonometric ratios, because that's what, so 6 trig ratios. Okay, so how do we figure out the 6 trigonometric ratio? We got the x, we got the y, we need the r. So we need to find the r first. So r would be 3 squared plus negative 7 squared equals to r squared. Okay, so we're looking for the radius. That's going to give us 9 plus 49 equals to r squared. It's going to give us 58 equals to r squared. So that means r is the square root of 58. Square root of 58. So this part here is square root of 58. Okay, so in this particular case, the 6 trigonometric ratio works for theta r only for right triangles. So from here, cosine theta would be adjacent over hypotenuse, adjacent, which is 3, hypotenuse, which is root of 58. Sine is opposite over hypotenuse, so it's going to be negative 7 over square root of 58. And then tangent is opposite over adjacent, so negative 7 over 3. Negative 7 over 3. These are the 3 primary trigonometric ratio. Now we're going to do the reciprocal. Reciprocal of cosine is secant theta. Okay. So if we want secant theta, we want the reciprocal of cosine. So it's going to be root of 58 over 3. Cosecant theta is equals to the square root of 58 over negative 7. And then cotangent theta is equals to 3 over negative 7. Okay. So that one is not so bad. It's pretty straightforward. We just had to figure out the r first, and then now we can state the 6 trig ratios. Now what we're going to do is find the angles. So find the angle there. We can use either the cos, sine, or tangent, but we have to be careful because our calculator, although it can do amazing calculation, it could not figure out which quadrant we are looking at. Okay, so even though it can calculate, it doesn't know that we are operating in quadrant 4. So if we use cosine theta, so now this is the part 2, or II, we can go cosine theta is equals to 3 over root of 58. Okay, let's calculate theta. cos inverse of 3 over root of 58. Okay, cos inverse of 3 divided by square root of 58. I'm going to get 1.17 radian. Now, let's see if this even makes sense to us. We are on, because we use cosine here, we have a positive 1.17 radian. The calculator actually thought that we are operating in quadrant 1 because cosine is positive. Cosine is positive in quadrant 1. It automatically thinks that we are operating in quadrant 1 when in fact we're operating in quadrant number 4. So the calculated information in here, so this is a reference angle. So our reference angle is positive 1.17. So what does that look like? So if our reference angle is 1.17, then we go here. This is going to be really, our reference angle here is 1.17 as well. Right there. Okay. So this is important that we learn this, the reference angle and the angle in standard position. So if this is a reference angle, how big is it from here to there? This is the angle in standard position. So how do we know from here to there? Okay, so theta is equals to, if we go all the way around, that's going to be 2 pi. But then we don't really go all the way around. We stop right here, which is, so we have to take away the reference angle of 1.17 radians. So 2 pi minus 1.17 radians. It's going to be 5.11 radians. So from here all the way here is 5.11 radians. That's the angle in standard position. Okay. Now this is theta in standard position. Oops. So how can we figure out the other angles? Because we have our domain from negative 4 pi to positive 4 pi. So we also need to calculate coterminals. Okay, so how do we calculate the coterminals? That one was from our lesson last week on Friday. So it becomes theta plus 2 pi times k, where k is an element of integer. Okay, so let's pick some integral values. So if we go, our theta is 5.11, so 5.11 plus 2 pi times negative 2. Okay, I'll just set it up and then we'll calculate this all together. Okay, so I've written down some values for k. So I use a -2, -1, 0, 1, 2, and then I'm going to end up with some coterminals in here, and we will later on find out which one actually falls within the domain of -4 pi to +4 pi. So if we calculate all these values in here, Mm-hmm.
Okay, she's done.
Okay. Can you give me a moment, please? I'm still doing this. Okay. Um, okay, hold on. Okay. So these ones are the ones that I've calculated that are coterminals. Okay. There's a limit though. Our limit is from negative 4 pi to positive 4 pi. So the domain is from negative 4 pi to positive 4 pi. And we said that negative 4 pi is approximately negative 12.57 and positive 4 pi is positive 12.57. So which one of these fall into this domain? So this one is okay, this one is okay, this one is okay, this one is okay. This one is, although it's a correct coterminal, but this is over because we only go up to 12. So this is not going to be part of our solution. So the solutions are these ones. Okay, so that's that. I think what I'm gonna do, I don't think I'll be able to finish everything that I wanted to accomplish here. Um, I'm gonna leave it here for now, and then we'll get us some time to do some practice questions. So let's take a look at the book and then figure out which ones you can practice on. Okay, so we are on page 4. Page are we on here? Okay, so you did 494. You did some questions over here. 494. I'm just gonna assign some questions and then we'll go on from there for you to try. Okay, so you did 4, 5, 7, and 11. I think last time. Hmm. I think you can just keep going with that one for now. You could do number 13. Okay, so you could try to do number 13, number 14. And those are it for now. So for today, just do the questions 13 and 14. Okay, so I'll give you that page number. So that's going to be on page 498. and up to 499. So that's gonna take probably a little bit of time for you to do. So please go through those questions. And if you have any questions that you want me to go over, let's say you were doing these questions and you got stuck or you're not getting the same answer, um, or you are getting the answer but not all of the answers, all of the possible answers, because you might get some answers for theta but not get all of the whole possible answers. Just let me know and then I will help you out. Okay. And also if you need help with um, figuring out how to use your calculator, again, you send me an email and then I'll try to get to your question right away. Okay, so for today, I'm leaving that with you. I want to also mention while this is on that your test on chapter 6 is going to be on Tuesday next week. That's going to be March 19th. Um, so make sure that you're keeping up with it and then trying the questions on your own, um, asking questions if you're stuck, and so on. Okay, so test on chapter 6 on May 19th. That's Tuesday next week. So that's a lot of time to actually um, to let you know ahead of time. Okay, so I leave that with you. Have a great day of learning or doing work. Thank you very much for listening and learning and participating in our YouTube channel here. So I guess I'll talk to you either later or I'll talk to you again tomorrow. Okay, have a great day. Okay, bye for now.
This is just on snooze. My sister